Hello and welcome to another one of D's ADD videos. Today we're going to look at correlation, covariance, and Pearson's coefficient. What is the concept of correlation? Well, correlation is a way of describing the pattern among two things and determining whether there's a linear trend in the behavior of those two things. So in other words, as one of them goes up, does the other one go down? If that's the case, then it is negatively correlated. Sorry about that. So the example I put here was the more television you watch, the more hours of television you watch, the worse your grade on your stat test is. For some reason my highlighting feature is not working properly. You guys get the idea. And then the more you study, though, the higher grade should be, right? And that's positively correlated. I'm not sure why it's not highlighting properly. I'm sorry about that. There we go. So the more you study, the more you exercise, the longer you can run. Things like that. So covariance itself can tell you that there's a trend there, but it doesn't tell you how far that trend is exhibited or to what extent they both go up together or how much television watching drops your grade. Okay, it'll just tell you that there is a relationship. So what we do is we calculate Pearson's correlation coefficient, and that gives us more of a concrete term. Well, these are the two formulas. This first one right here is take the deviations of each, multiply them together, and divide by n minus 1. This is the shortcut formula over here, and a lot of calculators will spit out the sum of x, y's, and the means, and this one's quick to use if you just enter the data in the calculator. But your test won't allow you to do that, so make sure that you know how to actually show the work. So real quick though, oops, wrong button. Let's try that one. This first one would be an example of R being negatively correlated or close to -1, because there's a pretty solid trend that as the x variable goes up, the y variable is clearly going down, and you could best fit a line through there using regression analysis, which has its own separate video. Okay, this one here would be an R value, R for sample, rho for the population, right? Because there's no clear trend here, you can't really make a line out of this chaos. Whereas on this final one, oops, let's remove that. There's definitely a clear trend going up that way. So that would be a closer to 1 trend. Okay, so now you have an idea of graphically what to look for. R values, correlation coefficients, have to be between -1 and 1, as I just showed you. I already gave you these examples here, and R equals 0 means that there's no correlation. Be careful, don't make the mistake of thinking that correlation implies causation. It just shows that there's a trend. It doesn't mean that it causes it. So the formula for the coefficient of correlation here becomes this right here. Oh wow, it just doesn't want to highlight. I'll just try this side. There we go. So you do the deviation for the x, the deviation for y, multiply them together, and then you do the deviations and square root them individually. or you can use the shortcut formula over here. I'm going to have to work on that highlighting feature here. Sorry about that. But basically that's it for correlation and covariance. There is a way to do it with random variables, but that's its own video entirely. This is a concept video. Make sure you check out the example video as well. This handout is on my website, so you feel free to download it if you don't want to type all those notes. Alright? Thank you, and have a nice day.